we want to take a look at now is how do we prove that a quadrilateral is a parallelogram? And again, we had 4 properties of a parallelogram: definition and 3 theorems. If it's a parallelogram, opposite sides are congruent. If it's a parallelogram, opposite sides are parallel. If it's a parallelogram, opposite angles are congruent. If it's a parallelogram, the diagonals bisect each other. If we flip all those around, basically doing the converse of all of those are going to be our first 4 ways to prove a quadrilateral is a parallelogram. So let's just list them up here. 1, 2, 3, 4, and then we're going to add in a special 5th. So the first one is, now again, this is, I don't want this to confuse you. Opposite sides parallel implies parallelogram. This is the short version. Like when I say the short version, it's what we would typically write as a reason and a proof. But keep in mind, it is both pairs of opposite sides parallel. If I have both pairs of opposite sides parallel in a quadrilateral, it has to be a parallelogram. The next one's the converse of the first theorem we did. If I have both pairs of opposite sides, in class said, congruent. Congruent implies parallelogram. That's a bad congruent symbol, isn't it? Don't you hate that? Where'd my good eraser go? What? Do you have a good eraser and a bad eraser? I hate that. So now, this is congruent. Third one, both pairs of opposite angles congruent. Give me a parallelogram. Fourth one, if I could show the diagonals bisect each other, that's going to give me a parallelogram. Now this 5th way, this is one, again, it only works with proving a parallelogram. It doesn't stem to say it's necessarily a property of a parallelogram, because I don't know they would use it by itself. But the 5th way deals with if I can show that one pair of opposite sides are both congruent and parallel, it has to be a parallelogram. And let me just put like an example of that. So if I had this in here, it's not one pair of sides congruent and the other pair parallel. They have to be the same pair, right? So again, just put like a star next to that. That's the one that's not like the 4 properties of a parallelogram, but and it should make sense that like this was both pairs of opposite sides parallel, both pairs of opposite sides congruent, both pairs of opposite angles congruent, both diagonals had to bisect each other, and then now it was one pair of opposite sides, not both of them, have to be congruent and parallel. So those are the 4 ways to prove a quadrilateral is a parallelogram. Now we could look at some basic problems that say, are these quadrilaterals parallelograms? If so, give me the reason why. So let me grab one of those sheets from over here in my illustrious pile of sheetness, and let me put some stuff up here on the board. And we're basically going to say is, are these parallelograms? So let me erase this stuff first. And let's put let's see, which problem do I want to put up here? Blah, 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 blah. Yeah, I like these. So these were some problems from one of the homeworks that we just did where it said, and I'll read them to you and then see if we can draw them out. It says, in quadrilateral BLOT, segment BL is parallel to segment TO, angle BTO is equal to 80 degrees and angle LOT is equal to 100 degrees. Is it a parallelogram, and if so, by which method? So the first thing I would do it here, and there was no diagram, it was just a word problem. I would draw out a generic quadrilateral. Now I don't know if it is one yet, but I'm just drawing it as one. And it said BLOT, blot, right? So we're going to have to pick a letter and go either clockwise or counterclockwise around. So there's quadrilateral BLOT. Segment BL is parallel to segment TO. Angle BTO is this angle right here, is 80 degrees. Angle LOT is this angle right here, and it is 100 degrees. Make sure I got this right. BLOT. BL parallel to TO. BTO is 80. sorry, LOT is 100. So that's set up right. So now I would say, well, is this a parallelogram? So we look at this and we're like, all right, those 5 ways we just talked about. Both pairs of opposite sides parallel. Right now I only have one pair. So then if I wanted to use that method, I would have to say, can I say that the other pair is parallel? Well, they gave me some angles in here. Why did they do that? Because they love to quiz us, right? But again, I've got 2 angles. A transversal and 2 sides in relationship to those 2 angles. What kind of angles are they? With these 2 sides. Transversal, 2 sides, it makes that C shape. So the C shape is same side interior angles. If the same side interior angles are supplementary, then the lines have to be parallel. Well, I would ask you, is 80 and 100 supplementary? It is. So if 80 and 100 add up to 180, which they do, that tells me that these 2 sides have to be parallel. Now, is this a parallelogram? The answer would be yes. Don't stop there, because it's going to say, if so, give me the reason why. And the reason why in this case would be opposite sides parallel imply parallelogram. So pretty straightforward. And then there were a bunch of problems like that. But what I want to take a look at next is, can we now look at a proof that involves proving a quadrilateral is a parallelogram? Because that's really where we want to head with this. I'm like looking all over the place here because I keep putting down my good eraser and I can't remember where it is. I hate my bad erasers, right? So let me put that there for a second. Let me come over here to my trusty sheet and let's grab one of these proofs that involves proving something is a parallelogram.